halve rust.
In the past, the Soviet space program was shrouded in mystery. Missions were prepared in secret and revealed only after they had been completed. For a long time, there was talk of a giant rocket, at least as powerful as the American Saturn V, discontinued in 1973. The rocket was unveiled on May 15, 1987. The launching from the Space Center in Baikonur was even broadcast on Soviet television. Weighing more than 2,000 tons at liftoff, the rocket was aptly named Energia. It can lift 100-ton payloads, the weight of the U.S. shuttle, into low orbit. The Soviets had no intention of repeating the mistake the Americans made by replacing their conventional rockets with a new generation of rockets. While the Americans were unraveling the problems with their space shuttle, the Soviets increased their missions by using rockets developed nearly a quarter of a century ago. The launcher they still use to send Soyuz capsules into orbit is a direct descendant of the rocket developed by Kololyov for Yuri Gagarin's first flight. Paradoxically, the Soviet Union uses a somewhat capitalistic approach in its space industry. Rockets and capsules are manufactured in large series on an assembly line to reduce unit costs. More launchings can be carried out at a reduced cost. In fact, the Soviets have launched close to 2,500, or 80% of all the satellites in orbit, since the beginning of the conquest of space. A total of 2,000 Samyorka rockets were built. The production costs were so low that 10 rockets were manufactured for what it cost for one flight of the American space shuttle. The engines, which run on kerosene, look more like household burners than machines worthy of the space age. They bear no resemblance to the shuttle's engines, which burn liquid hydrogen cooled to minus 200 degrees. The heavy launchers in the Proton series are 3 times as powerful as the Samyorka rockets. In use since 1965, they are, however, as old as the Samyorkas. Used primarily to launch heavy loads such as space stations or interplanetary probes, they must be capable of reaching high speeds. These launchers use simple and inexpensive technology, and more than 100 samples have already been manufactured. After hiding the proton rocket for many years, the Soviets have offered to use it to launch the West's commercial satellites. No doubt they would like a piece of this highly lucrative market. The Energia has carried the Soviets through a crucial phase in the colonization of space. Unlike the Americans, the Soviets have been able to build a machine which is relatively economical to use. With a construction cost of less than $100 million, the entire Energia rocket costs a little more than one of the shuttle's 3 main engines. On top of that, the Energia is at least 20 times cheaper to run than the American shuttle and can carry a payload 5 times as large. Except for its low price, the Energia has the same principal characteristics as the American shuttle. The rocket consists of a main tank with 4 engines surrounded by 4 rocket boosters. Unlike the shuttle's solid propellant rockets, which gave NASA a great deal of trouble and culminated in the explosion in January of 1986, Energia's rocket boosters burn kerosene, similar to the kerosene sold in most hardware stores. However, its main engines are more sophisticated and, like the shuttle, use liquid hydrogen. It's the first time the Soviets have used highly advanced space technology. All the engines ignite at liftoff, providing a thrust of over 170 million horsepower. Once their fuel is spent, the rocket boosters separate and fall to the ground. The main engines continue before they too are released and splash into the ocean, where they're recovered. The payload capsule uses its own engine to reach its final orbit. Just as with the American shuttle, Energia's payload is attached to the launcher's main tank. The system was designed to place satellites and components of a space station into orbit and to be able to propel a reusable shuttle like the American one. Although Soviet engineers have not yet revealed their plans for a shuttle, Energia's power indicates it will be similar to the American one. In fact, American spy satellites have photographed a giant Soviet shuttle mounted on a bomber for gliding tests. The same spy satellites have discovered a giant hangar, 2 launching pads for the Energia, as well as a long landing strip for a large shuttle in Baikonur. Each of Energia's rocket boosters can also be used as individual launchers for a mini shuttle to transport cosmonauts into space. Like the American X-20 or the European Hermes, the Soviet mini shuttle will be launched by a conventional rocket and will coast back to Earth after its journey through space. A prototype of the mini shuttle has already carried out several test missions from the Kapustin Yar Cosmodrome on the Volga. After 1 or 2 orbits, the experimental spacecraft fell into the sea, where it was recovered by Soviet ships. The final version of the spacecraft will probably be several times larger than the one tested. It'll be able to transport a few cosmonauts back and forth between Soviet land bases and their space stations. In the long run, These recoverable shuttles will replace the Soyuz capsules, which can only be used once and have been around for the last 20 years. Since they were first launched in 1967, the Soyuz capsules have been used for approximately 60 manned flights. The very first Soyuz mission ended in disaster when the cosmonaut Vladimir Komarov died after having to make a forced landing. 4 years later, 3 more cosmonauts were killed aboard the Soyuz 11 when the capsule suddenly depressurized. Even though the Soyuz capsules have been improved over the years, they were born of a technology which is now obsolete. Once again, Soviet planners favored economy over technical sophistication. Without forgetting the goal of keeping their basic equipment economical, Soviet engineers developed the Progress capsule. These unmanned capsules were inspired by the Soyuz and are real space freighters. Launched by the same rocket as the Soyuz, they can be used to transport equipment and fuel to manned space stations. The Soviet space stations are unquestionably the most important aspect of the USSR's space program. They weigh approximately 20 tons and are 15 or so meters long and can house several cosmonauts for long periods of time. In 1971, Salyut 1 was the first space station in orbit. Seven more Salyut stations were launched later and have been visited by dozens of cosmonauts. In 1986, Salyut 7 was closed down and relaunched into a much higher orbit. It should be able to stay in space for another 8 years. An inspection team will visit the station in several years to study the aging of this type of structure in space. In February 1986, a new Soviet space station was sent into orbit by a Proton rocket. Called Mir, which means peace, this space station is the cornerstone of a space complex which will be manned on a long-term basis by Soviet cosmonauts. The new station, inspired by earlier Salyuts, has a docking module equipped with 5 coupling rings. Each of these rings can accommodate an interchangeable module designed to carry out certain experiments. The modules might contain astronomical observation equipment or experimental installations designed to study the biological consequences of weightlessness. The station can also accommodate new sections at either end. The first permanent module was attached in the spring of 1987. An astrophysics lab weighing approximately 12 tons, it includes an ultraviolet telescope and X-ray detectors for astronomical observation. The new scientific module has its own docking ring for a Soyuz or Progress capsule. With a capsule at each end, the Mir space station is more than 30 meters long. It becomes a cylinder where several cosmonauts can live and work comfortably. With the launching of the Mir space station, the Soviets took another important step toward the colonization of space. For many years, their manned missions have followed one after another with almost no interruption. Soviet cosmonauts have conducted numerous technological and scientific experiments while setting records for the longest manned missions.
Захваты у тебя, да, Володь? Ага, значит, Леня на фиксаторах, правильно? Значит, понял я. Понял, а у Лени... Раскладывали меня и заход. Сейчас сделаем, ребят. А у Лени зеленая? Зеленая, заход. Все годится. Значит, Володь, тяни на себя рукоятку синего цвета и опусти ее в горизонтальное положение.
Some crews have stayed in space for close to a year.
Как нас сейчас видно? Да, прекрасно. Прекрасно. Ну вот и хорошо. Да.
As a result of these long flights, Soviet researchers have been able to understand the principal problems caused by weightlessness. Of course, they have proposed solutions to these problems.
Как вы там на орбиту выходили за сегодняшний день?
Молодец, Витя. Ты понимаешь, мы вышли на орбиту 13 марта, и с этого момента с нее не сходим никуда в сторону, ни на шаг.
Soviet cosmonauts prepare for these long missions while still on the ground. They live and train in Star City, located in a suburb outside Moscow. They undergo physical training, which will help them withstand some of the stresses produced by space travel. They also rehearse all operations to be carried out in space by practicing on models. These models are placed in swimming pools to simulate weightlessness. Every manned flight, including Yuri Gagarin's first one, has been launched from the Baikonur Cosmodrome. This space center contains all the equipment required to prepare and launch Soviet manned rockets. The ground crews in the Mission Control Center in Kaliningrad, just north of Moscow, provide the follow-up support. Even though the Soviet manned missions are often spectacular, the exploits of the Soviet cosmonauts seldom surpass the feats of unmanned missions. Many meteorological, telecommunications, strategic, and scientific observation satellites have been launched by the Soviet Union since the beginning of the conquest of space. As a result, Soviet space technology has had widespread effect in the Soviet Union. The scientific aspects of the space program are also noteworthy. Without a doubt, the exploration of Venus is the crowning touch of a successful scientific space exploration program. During different Venera missions, automatic probes successfully soft-landed on Venus. These probes analyzed the soil and the planet's atmosphere, and then relayed this information along with exclusive panoramic photographs back to Earth. The Vega 1 and 2 missions further proved the quality of Soviet space technology. During these missions, in March of 1986, two highly sophisticated space probes rendezvoused with Halley's Comet. Besides providing spectacular photographs of the famous comet, which has remained intact since the birth of our solar system, the Vega probes analyzed the heavenly body in detail. Soviet experts are now planning to conquer Mars, which until recently they have more or less ignored. In 1988, they intend to send a mission to Mars and Phobos, one of its moons. Throughout the 90s, they plan to conduct a more complete exploration, which would include a manned flight to Mars. They have suggested this manned mission be a joint venture with the United States. Such an ambitious manned mission would take place at the beginning of the 21st century. A rocket capable of reaching Mars would carry a payload of 280 tons and be a great deal more powerful than any rocket in existence today. The docking of different modules required for the trip would be carried out in space. The Apollo mission may provide an example the Soviets will follow for the landing on Mars. One module would remain in orbit around Mars while the capsule landed. Once the mission is complete, the cosmonauts would return to the orbiting module and to Earth. Such a voyage would take 2.5 years. It would push human adaptability to space conditions to its limits. However, the exploration of Mars by humans is still just a dream. Yet in the USSR, people have used dreams to create reality. The exploration of space has always occupied an important place in the collective imagination of the Soviets. The pioneers of space development have been immortalized in the minds of the Soviet people. Yuri Gagarin, the first man in space, is a mythical hero, a model for generations to come. The Young Cosmonaut Club has even been created for those aspiring to contribute to the glory of their country by going into space.